you define economic importance and supply risk? They have some very long equations. I cannot give you details now, but if you download this link here, yeah, you find all these details. Supply risk means that the risk of getting these materials into Europe is high, because they're coming, most of them, China. They're coming from South America, they're coming from Africa, they're coming from Australia, so we cannot have them very easily in Europe. Or there are other things, because there are wars, there are commercial wars, there are several other issues. Taxation, additional taxations. You see what's happening between the orange leader from the one side and the Chinese from the other side. Orange leader, you know, I don't say the name. Donald, the leader. And the Chinese, it's getting crazy, because Donald Trump also imposes taxes to European goods also, and imposes taxes to the Chinese goods. There's a big discussion now in Greece, I think in Europe also, with all these parcels that are coming from China, that you have to pay 3 extra euros, etc. But the Chinese are not stupid. The Chinese now will create a big center somewhere in Europe, and they will transport all the goods in Europe, and they will distribute them through Europe. So they will avoid this 3 euro cost. But we think we're clever, but we're not so much. But anyway, so the red ones are the critical ones. You see some here, red dots, nickel and copper, which are also critical but are strategic. They have a high economic importance, but very low supply risk, because we produce them in Europe. But these here are strategic ones, not critical ones. So that's another sad story. European Critical Raw Materials Act that was recently approved from the European Commission, but the bad guys say that it was issued in order to avoid any progress in Europe about producing all these critical raw materials. I mean, in Europe, you know, we discuss a lot and we do nothing in the end, or very little in the end. I'm a very bad guy sometimes, so I use as an example this bloody summertime. Probably you remember that. They spent I do not know how many millions of euros. They made also surveys in Germany. I think they voted something like 4,000, 500, nothing. In Holland, 2,000. In Greece, maybe 500. Nobody cares about it. They made meetings in Strasbourg, in Brussels, I don't know, throughout Europe. And after 5 years and spending, I don't know, €500 million, they decided, clever, so let's abolish this, abandon this. So much money was left and spent and nothing happened. It's the same with critical raw materials. You see later that it was something else discussed this year, and a new body that I do not know what's going to happen. So the critical raw materials, in principle, wants to strengthen domestic supply chains and also reinforce these words from the Critical Raw Materials Act, international engagement to develop mutually beneficial partnerships with third countries. Very beautiful. Once I was, when I was a national representative for research issues in Brussels 15 years ago, and I asked something as a national representative, they told me that we are in the process of initiating this issue. If you understand what they're talking about, tell me. They are in the process of initiating. At the end of the process, they started to initiate it. It progressed, but they're lawyers, you know. I will say later, because all the Chinese leaders are engineers. All the European leaders are lawyers. This is why nothing moves in Europe. And I think also Germany, that was the locomotive of Europe now. I think in the last years, with all these lawyers, you're not doing very well, I think. You have to change something, the pace, I think. Because we count on you, but, you know, it's Brusselsization of Europe. So you talk a lot and you do nothing. So I have 2 short videos. Mari, can we do it through here or? No, yeah, just a minute. Oh. Probably have to stop this here. It's 1 minute and 3 minutes. It's nothing. It's complicated. Sound.
Running here, but not running there.
Is the motor died? Okay, let's leave it. I mean, it doesn't matter.
Okay. Just let's continue.
Let's leave it. Let's continue. Okay. Okay. No, it's okay. It doesn't matter. There were some short videos, 1 minute and 2 minutes, just to see a few things. Go on. Okay. So just to get an idea about these critical metals, a typical iPhone, I don't know how many of you have iPhones, but it contains 0.034 grams of gold, 0.34 grams of silver, some palladium, some platina, a lot of 25 grams of aluminum, and 15 grams of copper. Most of these metals, we do not produce gold in Europe, we do not produce silver in Europe, we do not produce palladium in Europe, we do not produce platina in Europe. So most of them come from China, come from South America, come from South Africa. So the supply risk for these metals is very high. We produce only copper, a lot of copper, and aluminum, of course. But all the other things, metals, we produce nothing. So the funny thing is that when we throw away iPhones, 1 ton of iPhone contains approximately 300 times more gold than 1 ton of gold ore. So if you excavate, get a ton of gold ore, you better get iPhones, because you get 300 times more gold, and also 6.5 times more silver. So, like a ton of silver ore. So this highlights the need for recycling. That's why also the European Commission, I was evaluating last month proposals about recycling. Recycling is very important, because we can get all these critical metals that we cannot get easily from China, because China imposes export taxes, anyway, other bans, etc., etc. So recycling is very important, and we discuss also later about it. So we see that it's something that we can do it in Europe. There are some also in Germany, some companies, and in Belgium also, and in Norway. There's some major companies, recycling companies, state of the art. The point is how long they're going to survive, because with all this, I'm not against environmental legislation, production is getting very expensive in Europe. And all these rules and directives about emissions, etc., etc., etc. I was discussing also yesterday with a few people, and also a few days ago, that we try to save as engineers something, develop a new process, save some tons of CO2, and they have the war in Ukraine and the war in the Middle East, and they produce so many more tons of CO2, which is, it's stupid that no matter how hard we try, we do not save anything in the end. So another sector is the renewable energy. Renewable energy depends very badly on CRMs, solar panels, aluminum, copper, silicon, wind turbines, rare earth elements for the magnets. No rare earth is produced in Europe. 95+% are coming from China. So as Europe accelerates towards decarbonization, etc., etc., if this trend keeps the pace, because I do not know what's going to happen with this, the politics from Trump administration, etc., how this Europe will be affected. So the demand for these materials will increase. So we will need more and more of these materials. So this is another stupid example of European bureaucrats. So when I, as an engineer, I see that lithium 240 with 186, if I was one of my students, he would not pass the course. So if you make an estimate 30 years later and say 86, I think they're capable also of putting some decimals also, 86.22. So this is what the Excel does. I mean, if you give a projection in Excel, you get decimals and you get something like that. So, I mean, an old Greek engineer like me, or I guess also an older German engineer, would say 600, not 586. But this is what Europeans think. 179, 2040. So we meet in 13 years, 14 years, and see if these projections are good. But anyway, we get the trend. So according to what we know today, lithium will be, the demand for lithium will be very high. And also demand from graphite, for nickel, etc., etc., etc. So I have several slides. I'm not going to stay on this, but since some of you are involved in these sectors, just to get an idea how many raw materials you need in robotics. Many, and many critical raw materials. I'm not going to read them, but just I have them here, it's for you. So this is more important. This is the materials, the critical raw materials we need for robotics. These are the critical raw materials. And this is what Europe 27 produces, sorry, 2%. 2%. This is process. Do not use these critical raw materials as they come, because we need, for example, aluminum alloys. We need nickel alloys. So we produce some of these alloys. Okay, if we go to production, we do it 21%, but very low, because robotics is a very strong sector, right, in Europe. Components, 4%. Assemblies were good in assemblies, 40%. But in order to reach assemblies, all these critical raw materials, we need also the components. So it's a sector which is very strong in Europe, but see that production is only 2% and processing is only 21%. So if we move to drones, another very important sector of the European economy. So several critical raw materials, we do a bit better, but not very good. 13%, EU27, of this material. Processing 27, components 13, assemblies 9. 3D printing, again, many critical raw materials. Only 9% of these are produced in Europe. Processing, we do a bit better here, 54%, and assemblies, 34%. So all these materials, if we put into the frame the defense also applications, very important sector, and we see that Europe invests in a lot of money also, or will invest in the next years in defense applications. So we need 39 raw materials. Out of these 39, 22 are critical. And for these 39, we produce 47 processed materials. Because, for example, why more? Because if we have nickel, we have several nickel alloys for different applications. It's not only nickel. Nickel, you have ferronickel for steel. You have nickel something for another application. So we produce many more materials from this. So this is something that you cannot see it very clearly. These are the critical raw materials, and dysprosium, or you see all this samarium, neodymium, or the rare earths with the highest supply risk, and the sectors they're used: aeronautics, land, space, missiles, etc., etc. So very important materials for this EU defense industry. We go to another initiative, let's say. 1 year ago, almost 1 year ago, March 25, 2025, the European Commission adopted 47 strategic projects. Projects that they are important for the European economy. So these strategic projects will be implemented in member states. So these 47 projects will be implemented. We'll see if they will be implemented in 13 member states. They target 14 out of the 17 strategic raw materials. 25 projects involve extraction of metals, 24 processing, 10 recycling to substitution. Extraction means find the ore, extract the ore. Processing is that to process the ore to get, let's say, the metal, or in a good form, the metal. Recycling, okay, you use used products, let's say electronic equipment, other equipment, use magnets, use batteries, whatever, to extract metals. And substitution, only 2. There is quite a lot of research on substitution, try to find, let's say, substitutes for critical raw materials we do not produce. If we, let's say, if we do not have aluminum, we can produce magnesium, for example, which is quite similar, not exactly, but we can substitute aluminum in some applications with magnesium. So if you add this you do not get 47, you get more than 27 because 47, because some projects may involve extraction, processing, plus recycling. So some projects involve more activities. So just to get an idea, 22 out of these projects are related to lithium. Just to see the importance. 12 nickel, 10 to cobalt, 7 to manganese, and 11 to graphite. So just to see which are the metals, the critical raw materials which are important for the European economy. Also, one project is magnesium, and 3 projects is tungsten. Regarding tungsten, there's a lot of tungsten in Ukraine. And also, I know that the European Commission tries to get some MOUs with the Ukraine government to get some tungsten mines, which are not in the areas of the that we have activities, war activities, but central Ukraine or close to the Polish border. So they try to, I don't know, see what they can do with them. But personally, I'm not very optimistic because you see what happened with Greenland. I mean, Europe several years ago, they've signed a memorandum of understanding with Greenland. And then we talked a lot, right? Committees, trips, etc., etc. Donald Trump came and said, my Greenland is mine. I don't know what's going to happen in the end, but probably we've signed an agreement and we have nothing in the end. So this is how we work. I'm not very optimistic. I hope you're the younger ones do better. But anyway. So those projects were for inside Europe. A month and a half later, June 4, 2025, the Commission adopted 13 strategic projects. So projects that are important for Europe were Canada, Greenland, Kazakhstan, Norway, Serbia, Ukraine, and Zambia. And the other 6 are far away: Brazil, Madagascar, Malawi, New Caledonia, etc., etc. And of course, United Kingdom. Too close and too far at the same time. They have another prime minister. Let's see how to do now. It's a funny story, this. So the question is, okay, so many strategic projects, but for these 13 projects, the capital investment is approximately 5 billion euros. Who's going to provide this funding? The European Investment Bank? Somebody else? The Chinese? I don't know. Well, the Chinese for us, but if we do not provide any funding, probably the Chinese will go there, or someone else will go there to take advantage of it. So, okay, I recognize that there are many trials and initiatives in Europe, but from the moment they decided or they adopted until the moment that they implement it, it takes very long time. Because as a metallurgical engineer, I know the mining sector very well. The big problem in Europe that from the time you find a deposit until you mine it, the average time is 15 years. If you're a businessman, are you going to invest something that you get some money 15 years later? No. You better go to a Greek island, open a pub, and then you get rich in 2 years. I mean, to invest in mining or do something else. I do not know. So Europe has a long mining history. Okay. The European Investment Bank has financed a project in Finland. It's a caliber lithium project. So we hope, I say we, our university is involved, soon they will get some more to produce the first European lithium. The other company, apart from Caliber in Finland, is Savannah Resources. And in these 2 companies, we have them as partners in these 2 Horizon Europe projects, as our ongoing projects. In Finland, the situation is much better. In Portugal, there's a big opposition. And it's also, South Europe has a different attitude or mentality against mining. The funny thing in Portugal is that Portugal produces lithium for about 40 years. And the Portuguese lithium goes to mugs. Most mugs to get coffee, they contain lithium. But this is a Portuguese company. That Savannah Resources is a Portuguese, Australian, South African, you never know. So the Portuguese think that we don't like foreign investment to produce lithium. So they start to complain, and they have also very aggressive demonstrations, etc., for the same area, for the same mine, with the produced lithium, which is directed in different sectors. It's not another funny story, but we have to live with that. So anyway, we as Technical University of Crete involved in several projects involving these critical raw materials. Is another, we discussed, very important sector, because without recycling, we're not going to have the quantities of the critical raw materials we need for our industry. Because, for example, I know that Germany has a very strong photovoltaic industry. And we need raw materials for that. Not to mention manufacture of trains, of cars, etc. All this, I mean, we need for electric cars, we need for batteries, we need lithium, we need nickel, we need cobalt, we need so many critical raw materials. I mean, if we do not have them, so can we produce only the frame of the car without the battery? How the car is going to move? So this high diversification is very nice, a very core objective of this European Union Critical Raw Materials Act. But some, concrete results. It takes time, and China is moving much faster than the way we move. I remember. Tell you something now. It's not. I think it was 2008, 2009. I was invited to a very close meeting with it was something like 5-6 academics and something like 50 CEOs from a major European company. So CEO of Volkswagen, Nokia at that time, and the title was, there are no notes or meetings about this meeting, but Metallurgy 2050. Which metals the European industry is going to need in 2050? And I remember what the CEO of Nokia said, 2009, I think it was, that if we have this policy as Europeans, Nokia is not going to survive for more than 2-3 years. And indeed, 2 years later, Nokia was liquidated and was absorbed by an American company. So this is, because it was very expensive, because the Chinese produce very nice chips and very nice electronic devices at a very low cost. And we have also high extraction cost and high processing cost, because we have to pay higher salaries, and that's good. We have also the environmental directives we have to obey. So the production of a metal is getting much more expensive, so we're not competitive. My son does not care if this cell phone is produced with, environmental way. He cares about his student what's cheaper, and we'll buy the cheaper one. We'll not buy the most, green one or the most environment-friendly iPhone. So most people think this way. So there's a lot of innovation, a lot of, many activities going on exploration. Exploration is, where do we find these ores to produce the critical raw materials? Mining and extraction, despite the problems we have. I take as example Crete, a very touristic place. Everybody wants the quarries next to his resort, because he gets cheap aggregates to build a summer house or a new hotel. But from the moment he builds the hotel, does not go to the quarry anymore, because the tourists are, annoyed by the explosions, by the dust, by everything. So we need the raw materials to do something as cheap as possible. But as long as we build, let's say, our road, our house, our hotel, etc., we do not need any mine activities nearby, because the tourists are distracted. So that's a human mentality. That's true. And it's something that we have to live with that. I had some very nice videos, but you see it yourselves. Boliden is a multinational company based in Finland, based in Sweden also. In north of Finland, north of Sweden, because they have also cheap energy there, you ship electric trucks of 300 tons carry ore, like trolleys. They do not need anything, which is very good because it's a very green, let's say, production. Because I travel 5-6 times a year in Finland, I know it very well. I mean, it's a country that I think the people trust the government, which does not happen easily in at least in South Europe. Okay, in Germany, it's much better situation, but in Greece, it's not that good. And they respect the people, and they see that they take. I mean, we've been to those mines in the Lapland, and you see in the headquarters, you see cameras and you see screens showing in every mine the quality of the air, the temperature, the dust quality, how much, you know, it has greenhouse gases in the air. It's like, and if you go to the headquarters in the mining area, it's like a bank. I mean, it's very clean and very, very neat. It's very, very nice. But okay, that's another story. And the Finns are very happy because they have something like 2.5 months per year holiday. So they say the most happy people in the world. I don't know. Anyway, so something that maybe colleagues who are involved in information technologies may be interested in. This digital product passport. This is something that is needed in many sectors, also in metal production and critical materials production. So this is an important tool. I give you some definition also to make entire value chain. So, for example, this product passport trace the provenance, origin of material. So if you get, let's say, a scrap from a boat, from an old train, from something, and you want to produce new steel, you want to produce new product. So you have to know the quality. You have to know how was it produced. Was it produced from raw material? Was it produced from another scrap? Which is the quality? Which is the content, let's say, of trace elements? If it's steel, for example, what kind of steel? Is the good quality steel? Lower quality steel? What kind of steel? So you need all this information. Not only this, if you do landfill mining is just get, let's say, production of metals from waste. It's electronic waste, other types of waste. So you need all this information because for an engineer, it's very, very useful this. To know if I know all this information, I can very easily start the process. Otherwise, if I do not know the information, it takes time to do tests, to do a lab experiments to see which is the quality of this raw material and what can I do with this. So it's regarding processing, distribution, location, consumption, disposal, etc., and also production. How is this product made? How is it recycled? If it's recycled, etc. So there are quite many legal conflicts and principles for cross-border cooperation with this. We know that cobalt, copper, lithium, etc., are fundamental to clean energy technologies, also for electric vehicle batteries. Tracing their journey from mines, through markets, to even recycling is quite complex legally. It's not very easy to do this. So, which are these critical legal challenges associated with this implementing these digital product passports? I mean, we see them often in proposals. Many partners, you know, they say that we will develop this digital product passport, but it's not very easy in terms of, you know, legal aspects, etc., etc. So, if something is interesting, there is this link. You see that regulatory incompatibilities, mainly related to inconsistent categorization and non-interoperability. So there is an eyes also. So if someone wants to look deeper into this topic and study it, you can find quite useful information. There's a white paper. So, recent developments. A few months ago, the work program 2026 were approved, the European Commission announced plans to publish a proposal for a critical raw materials center. We have critical raw materials act, now we have a critical raw materials center. So I'm not very happy, I'm not very optimistic, I do not know how all this will be coordinated. You know, our past does not guarantee that we have an efficient future. That's another body, which is going to be probably bureaucratic again. So, according to that was, I think, published a few months ago, and in the second quarter, they said it will be operating. I don't think it will happen because it's summer now, everybody's on holidays. So, the center will develop this systemic intelligence on CRM value chain, in the entire value chain. I cannot give you any more information, that's brand new, but I copied this from this critical raw material center, what the objectives are. Let's hope that it will work quite well, but I do not know how it will, you know, cooperate with the Critical Raw Materials Act, which is not doing very well. And many countries complain that, okay, it was adopted a few years ago, but it's not, you know, we do not see that we have any benefits in Europe after 3 or 4 years regarding this critical raw material supply and demand in Europe. So there's another action, resource EU action plan, another action plan. Too many action plans, little actions. So we'll accelerate objectives. So if your raw material strategy will strengthen EU resilience against supply disruptions, support strategic projects. Strategic projects were adopted a year ago and 2 months, 14 months ago. This year, actually, they invited me also as an evaluator, but I did not have time. This time now, I think it started June, July, and August. The new strategic project will be evaluated. There's almost nothing done for the old ones that were adopted a year ago, because the biggest issue is finding money to start the projects. So they say the European Investment Bank. Okay, the European Investment Bank, they need also supporting documents. They need studies. I mean, if you do not have these studies, because when they made the applications, these studies were not necessary. So they got some, you know, proof of concept, but it's not that, you know, business plan or something else that to justify that this is needed. So, so benefits for this strategic value chains. So 2025 was 95%. This third country, we do not say it, but it's China. They hope that in 2030, with this strategic project, it will drop to 42%. If it drops to 80%, I will be very happy. 42%, forget it. It's like I say, I go to Germany, and next year I will be champion. Forget it. Bayern Munich will laugh. It's the same. I mean, rare earth processing, 100% dependency. See, dependency, 100%, 20, 30, 60%. Probably these people were drunk when they gave these figures. So these are the official figures. So I say this is wishful to be seen. If we're all okay, in 3 or 4 years, you'll be again here, we can discuss this, see who is right and who is wrong. Main conclusion, not to bother you too long, because I had some 10 minutes video, but anyway. So Europe has strong mining and processing potential. In innovation, we do very well. But the problem is that we develop technologies to produce, let's say, batteries for electric vehicles, but we need the companies to produce the batteries. We are very good in several institutes, Fraunhofer in Germany, several technical universities in Germany, they do excellent research. But in order to produce this bloody battery to put it in the car, we need the company to produce the battery. I cannot go with my results from the lab and produce a battery. So that's a long way, I think. Mining has a bad reputation in Europe. Okay, this will take time to change, if it changes. So, my view, Europe needs vision. And my motto is that European leaders are lawyers or accountants. So I do not see too much, vision in that. I mean, okay, it's not a nice discussion these days, but just think about leaders in Germany when I was a student in the 80s, leaders in France in the 80s, leaders in Sweden in the 80s, but you know, and leaders today, and compare. At least the Greek leaders are accounted the best of them. The other ones, anyway, they say what's cheaper today? Cheaper bananas. Okay, we import bananas from Brazil. Tomorrow, if bananas are cheaper from India, we import bananas from India. We have the same problems with sugar plants. In Greece, we had several sugar plants that were all, you know, destroyed because they were getting cheaper sugar from Brazil. Again, with the fishing boats, the fishing industry was destroyed. Many industries were destroyed in Europe, and okay, we will die in a very nice environment. So, can CRM reshape Europe's economic and technological resilience? I don't know. So the younger ones have to do better than us. And these are the projects we are involved related to critical raw materials. I wish I'm wrong, but I do not know what's going to happen. That's all. Thank you very much.
Thank you very much, Professor Komnitsas, for this, I would say, very interesting talk. Are there any questions from inside the audience?
Well, thank you very much for sharing your insights. And I was surprised your outlook, it's quite pessimistic if I interpret it the right way. So my question to you, do you also see some hopes, some focus fields for innovation? I learned that recycling may be one of the big hopes that you mentioned. Are there more, or do you have more specific examples where we can also justify some hope? Or is it simply that we put everything to the next generation and rely on their capabilities to develop these innovations?
Okay, I work in this sector for almost 35 years. I participated in many projects. I've evaluated many projects. I've known many people in almost every country. I cannot give you specific information. It's forbidden, but I will tell you that, for example, several years ago, there was an excellent German team from Fraunhofer. They produced something, and they applied for a continuation of this project, and the proposal was rejected. This is a big problem, that we do not reward good teams in Europe. So if they, let's say, spared some money, because the problem is that, you know, for those of you, you know about European research, okay, we apply with Michael a project, say we go to TRL 5. We reach TRL 5, and we apply for a continuation of it to go to TRL 7 and 8, and the proposal is rejected. So what is missing, I think, because there is a very strong potential in Europe. There are many good teams, they produce very good results. Because at least 1 or 2 times a year, I participate as external evaluator of ongoing projects. So the results are very, very good. But the point is, from the time I reach TRL 5 or TRL 6, I need the money to go to TRL 8 or 9. And nobody gives me this money. Nobody gives me this money because they consider, they see that, you know, maybe there is a risk. Maybe if I finance TU München or TU Fraunhofer, or I do not know, Aalto University or the Greek University, probably there's a high risk of losing my money. That's the big issue, that there's no, let's say, innovation needs investment. It's like if you're Bayern Munich, you buy good players. Yeah, I like very much Bayern Munich. You buy good players and you have an excellent team. You cannot build an excellent team with bad players. That's simple. So you need to pay money to buy good players. So you need to pay money to finance the good teams to go from TRL 5 to TRL 8. If you do not give them money, because if you give them money, probably other countries will complain, why do you give money to the German institutes and not to French ones and not to whatever, then you cannot, the chain breaks, so you cannot proceed. So this is the biggest issue. We need, I don't know if it's a European Investment Bank, whatever you name it, but if you have good results, some people should be rewarded. I mean, in Europe, we have, okay, democratic procedures, okay, but someone who spends a lot of effort and reaches a certain point should be rewarded. There's no rewarding. There's no rewarding. That's. I think this is why I'm pessimistic, because you know I have to apply again. And now with AI, I mean, in all, I mean, because I participate every year at least once as an evaluator, you could see 20 proposals, 25 proposals, and 4 or 5 proposals were funded. So about, let's say, 15 to 20%, the success rate. This year with AI, and with these openings of Europe to Kazakhstan, to South America, to Australia, to Canada, the number of proposals has tripled. And because Europe spends a lot of money now for the defense industry, the budget is smaller. So instead of financing, let's say, 25% of proposals, 20%, you finance 7 or 6. I was saying to Michael yesterday, better buy lottery. Because I was participating in the call, 52 proposals, 4 would be funded. That's very difficult. So people also are disappointed. The people. That's because if you have a hope that if you apply something that will be rewarded, you try. If you say that, okay, I don't see any future, I will apply, and it doesn't matter, probably I will not be funded. And then you apply again the same proposal. Next year you apply again with the same proposal. You don't know any changes because you say that, yeah, its chances are so little, so there's no need to invest time on that. So that's the biggest problem.
Do you think the Americans and the Chinese are doing better in this innovation pipeline?
Are doing better. The Chinese
Can we learn from them?
Yeah, the Chinese definitely are doing better. The Americans, I do not know. I don't think they are doing that better, but the problem, I do not know if you're familiar with American universities. I mean, if you get money from an American organization to do research, I mean, in Europe, they say 55% salaries, 20% travel, 10% consumables, overhead and plus that, so they make a budget. In the US, in most Department of Energy, I mean, big US organizations, they give you the money, they want the product. We do not care how much, how you spend the money. If you pay salaries, if you go trips, if you buy consumables, if you buy equipment, whatever, I need the product. That's the biggest issue. That's the product. I mean, I need a lithium battery. I do not care, because in Europe now, you go to a trip to present something, they say, yeah, the hotel was expensive. Justify why the hotel was more expensive. Yeah, because once I went to Brussels, they had the full week. Hotels cost 250 euros, the cheapest one, and they had to justify why the hotel was very expensive. I mean, we spend too much time to justify nothing, really. That's the biggest, issue.
Yeah, thanks. Very nice talk, actually. And how do you see, like, even after the research phase, like if you go to you said that the mines take in Europe 15 years, right? It's a very long time, and investors don't like anything above 7 years, let's be honest, right? So and to 7 years, it's not gonna be easy to come to that at all. How do you see that even this gap then in the final project phase, even if you bring it into real world, let's say TRL9 then, when the money is like, I don't know, 50, 100 million, right? And investors are shying away because of not political uncertainty, but like also community uncertainty, right? Of protests and so on, and financing uncertainty for the long gap of 15 years. How would you improve it there? Because just throwing money on the problem is also not solving, right? The issues with communities and so on. How do you see it there?
Yeah, it's not very easy, the answer. But I think if we're going to do something, we need a common framework to work. Because if the framework in Germany is different than the framework in Finland, is different than the framework in Greece or in Cyprus or in Portugal, it's not going to work. I mean, work on environmental subjects. I'm not saying that we have to put the environment to emit CO2 billions of tons, etc. But there should be something. We cannot endlessly talk and talk and talk. And also, I mean, we're talking about space technologies, about new trains going, but the Chinese, they produce Chinese trains going 600 kilometers per hour. And what do we do? What do we do? I mean, if you say I'm going to invest in areas because I need the magnets for the trains, these super fast trains, I need the magnets. I mean, if there are deposits in Europe, if I find something, I mean, how am I going to produce a magnet? If I depend on the Chinese, I mean, of course, the Chinese will take advantage or we do something that's against us. Eh? And what do we do? And I think we have to find something. And okay, you're younger, but I think, the European Commission tries to satisfy now 20, I don't know how many countries were. So everybody has to be slightly satisfied. If Germany is right, Germany will not get the lion's share, will get something because the French will complain, the Spanish will complain, and so everybody has to be slightly, happy. You get something, I get something, you get something, so nothing is going on in the end. Eh? So we need a common framework, and on the same time, don't think that's easy, but so something is efficient. Why United States does better? Because they have one government. Because they have one government. That's very clear. And for example, if a new directive is voted in Brussels, all the countries 5 years' time to adopt this framework. So something has to change. I do not know what has to change. I think it has to change the vision. And I believe me, I'm not going to talk about politics, but you had Willem Brandt, France had Mitterrand, Sweden had Olof Palme. Politicians, no. Britain had Margaret Thatcher. No matter if you agree or not, but they had a vision. Wrong or right, they had a vision. So today, we don't have a vision. Do we need to support the industry? Do we need to support the innovation? Instead of producing Critical Raw Materials Act, another strategic action plan, another action plan, something else, more committees, more discussion, we have to do something. You don't do something, sorry, I'm not optimistic at all.
Thanks a lot. I agree, actually. Yeah, it's quite difficult there.
I have one more question, since you mentioned initially that you also into the environmental assessment of the critical raw materials, and in your presentation you mainly talked about the resilience and strategic independence as a motivation for the CRM and so on. What's your perspective on the environmental side? Do we have a chance to do any better through the CRM Act, or will it even maybe worsen the footprint because we don't have so high quality ores and so on, and we have to do more processing and so on? So is there a co-benefit from the environmental perspective, or is it simply stays the same but just a little bit different?
It's a very good question. Okay, I'm also working on life cycle analysis. I also calculate footprint, but if I speak frankly, if you ask your grandfather or maybe your father, people, I think in the 50s and the 60s, did not care so much about environment. But as an old engineer, my professor in Technical University of Athens said that engineers have always an environmental thinking, because when you develop a process, you want the process to be energy efficient, not to spend too much energy. You don't want to produce too much waste. You don't want to spend too much water, because it's engineering thinking. You have to produce a process which is good. In the 50s, yes, and cost also. Exactly, and also if you produce waste and you dispose the waste, you have to pay a fine. So this is real cost also. So when you develop a process, it has to be cost efficient. If it's cost efficient, it will be environmental good and socially good, etc., etc. But in the 50s and 60s and 70s, nobody talked about the environmental aspects because the priorities in Europe were different at that time. So now we have a better quality of life, we focus too much on the environmental aspects, and we also miss the point sometimes. Because, as I say, okay, how much, I mean, so much money is spent in every framework to develop new processes with a lower footprint, et cetera. And when I look in the Ukraine-Russian war, in the Middle East war, I mean, there are some estimates. I mean, the Europe has to, let's say, not to produce nothing for 20 years to equalize these emissions that were. There is a war in Ukraine. The greenhouse gases do not stop at the German-Polish border and say Germany is a green state, so we do not enter Germany. Or if something happens, they say there's a Greek, island, so we do not enter Greece. So, I mean, okay, we have to make some compromise sometimes. I mean, we're talking about zero waste. I get so frustrated, Zero waste. Do you produce at home zero waste? Unless you eat chicken and you eat the bones also. Okay, you take the bones and you make compost, whatever. But it's a bit, sometimes we develop terminology which is useless. Okay, we can think about recycling waste, but zero waste is, I mean, I read sometimes in a harbor in Greece, zero waste port. What does it mean, zero waste port? I mean, when you have these cruise boats with 3,000 passengers, and they eat, I do not know what they eat. And they go to the toilet every day, 2-3 times, and drink so much beer. I mean, how can you have a zero waste or a zero waste cruise? I mean, they're nice words for the people, but in practice, what's going on? I don't know. I'm just trying to be, sometimes provocative. Because through this, you can maybe urge some people to think about it. Because if you're politically correct, if you say everything is fine, if you say it doesn't matter, as a father, I mean, most fathers, I think, even mothers also, they say to the kids, it doesn't matter, it doesn't matter. Our fathers do not say that nothing matters. They say sometimes something matters, but today we say it does not matter. And sometimes you see a different mentality of the young people. Then they say it doesn't matter, whatever they do, it doesn't matter. So it's a different way we look at things. So we do not have to become, like the teacher, my teachers, or that we're aggressive, etc., etc. But sometimes we have to face reality. We have to tell him, no, it matters. So you have to be careful. You have to do this. You have to do that. If you always say it does not matter, I do not know what comes in the end and what's the outcome. So in case you need in the future any assistance, any help, any whatever, feel free to contact me. I have also emails. If everything, if Mario here and Mike here.
Further questions? Further questions? Otherwise, we will not bother more the professor. We had this really,
very nice,
really pragmatic discussion. I think we
nice
just removed the pink glasses and we saw the reality in a sense. And in a certain amount of time, we need such discussions to realize. But I will say one word and just close this talk. Rearm right now.
Yeah.
Thank you very much again. Thank you very much.
I also thank you. It was really very nice being here, and
Yes.
because we're the crazy ones here, work a lot, and it's nice to from the daily routine to come and have some discussions like that. So it's really fascinating, and not stay in the office and trying to play with all this finance of these European projects, because it's a pain in the neck. It's the worst part of a European project, finance aspects.
Finance aspects, I agree.
And you're talking about, not big amount of money, something like
Yeah.
500 euros. Why did you stay a night longer? Because I found the cheaper ticket, but you have to write why the cheaper ticket was cheaper.
Exactly.
But sometimes it's funny. I tell you, I was the last 6 months twice in Finland, Aalto and Oulu, into two PhD defenses as external examiner. And they do not ask any. I mean, in Greece, you need the boarding pass. If you have to get boarding pass, you have to contact your airlines. Once when the kid was small, I mean, I was carrying the kid and the boarding pass in my teeth. If I lose this boarding pass, I will be in trouble. In Finland, they say, we do not need boarding passes. We see that you're here. We hope that you go back. So we do not need boarding passes. So it's just simple accountant practices. And not all these things. And then, for example, I know in Finland that sometimes they tell me now that if you want to buy something for your lab, I mean, you do search yourself and you say that this, I don't know, computer or reagent or reactor was cost efficient. What does it mean cost efficient? Cost efficient cheap. Because in Greece, you have to buy the cheaper one. So I may buy something which costs 200 and the other 250. I have to buy the one which costs 200. But that one 250, it says if it breaks, the person says that I will come to university and then pick it up for you. And I will repair it for you within 3 days. The other one does not care, but I cannot use this. I have to buy the cheaper one. So if it breaks, I throw it and buy another one, which again will be the cheaper, but it's not cost efficient for me. So I get lost in these accounting practices and get frustrated, and we call the rector and we say bad words to my friend here, because what's this happening and this.
I think we have one more comment or question from the director.
I just want to take 2 minutes from this discussion, and I want to thank sincerely and from the depth of my heart our good colleague and good friend and excellent professor Konstantinos Komnitsas, who is very active on the European Commission, the European Union. In fact, Kostas is a visionary person, and the provocative way of bringing things always has in mind the areas of development and the collaboration. Might not collaborate, but Kostas always has the opening to see that interdisciplinary research is very interesting. And I want to thank him because he was the link that brought us to this project. And environmental, our area is in environmental, let's say, surveillance, but the aspects of minerals and mineral effects on the environment is the first time that we face that, and we see how much interesting is this area, and how the area of image processing, let's say signal processing, can be expanded in this all these aspects. And I would like to thank him and say that again, that he is the best person for interdisciplinary research, and for this reason he is very popular in the European Commission, and he's always traveling. Good. Okay. Same.
And then there's a minor detail that we have to invest the same year.
Thank you very much again. Let's take a break of a few minutes and then we continue with the next talk, which is about some digital shadows. I think already Professor Komnitsas said a few words about the digital passports, but we're going to see more. So just have a break and we are back in about 20 minutes. Όχι, εντάξει.
Ωραία.
Αυτό είναι όλα.
Αυτό που το βάλω εδώ. Είπα,
Παίζεις μπάλα σε αυτή την περίπτωση. Εδώ, δες με.
εντάξει.
Εσύ κάτσε στα νότ, κάνω το προσθές.
Εντάξει, δεν αλλάζω τίποτα.
Ένα καφεδάκι, άμα θέλετε πράγμα.
Δεν αλλάζω πράγμα, Μαρία. Εντάξει είναι.
Μισή ώρα θα έκαμε, τι είμαστε...
Τώρα θες να μην τελειώνουμε σε μισή ώρα. Εχθές τον παίρνω Γιώργο για να ξέρεις και του λέω έλα σου πω, του λέω μισή ώρα με έχεις βάζει στο πρόγραμμα, 25 και μια 45 λεπτά σε έχω υπολογίσει.
Κοίταξε, και πρέπει να γράψεις 50. Θα τα καταφέρεις μισή ώρα.
Σε παρακαλώ. Άμα δεν έχεις τι να πεις, θα πεις 10 λεπτά.
Α,
Έλα.
η Φερνάνδα μου θέλει να σου δώσει feedback για το concept note. Εντάξει, ρε παιδί μου.
Η Ειρήνη.
Είναι η Χριστίνα.
Η Χριστίνα. Εντάξει, παιδιά, θα το δω απλά σιγά σιγά γιατί γίνεται χαμός. Δεν προλαβαίνω. Φαντάσου την Κυριακή ήμουνα σε φάση, δεν προλαβαίνω να τα κάνω όλα αυτά. Όχι, θα το κάνω όμως. Αυτό έλεγα με τον Αρμπατζή χθες, ότι αύριο θα το πιάσω να το δω αυτό. Θα της μοντάρω εγώ το excellence όλο, να της το τελειώσω μέχρι τέλος της αλληνής εβδομάδας, να το πάρει που της είπα. Να μην αγχώνεται.
Άμα είχες το σύντομο journey, θα έλεγα ότι μου είχες κλέψει όλες τις προσέσεις. Έχω ακριβώς τα ίδια χρώματα. Λίγο χρυσό και λίγο πουρο αυτό το μπλε. Όλες μου υπάρχουν όλες έτσι.
Εγώ το έκανα πρώτη φορά στο εκλεκτορικό με το χρυσό. Δεν είχα βάλει τον άχρηστο ξανά.
Αντίστοιχα, είχα πολλές φορές και χρυσά γράμματα.
Ναι, είπε εδώ. Όχι, όχι. Σε αυτό που έστειλε ο Μάριος είναι μία. Σε αυτό που έστειλε στο mail. Στο flyer είμαι μισή ώρα.
Εκεί τώρα ξέρω.
Δεν θέλω pointer. Είναι γιατί κατέρχονται να δείχνει. Ας το μέρα, δεν πειράζει. Δεν λέει εδώ ρε γάμο το τέτοιο. Δεν το έχει εδώ, Ήθελα να δω το τέτοιο, το σίγουρο, το flyer. Δεν πειράζει, εντάξει είμαστε.
Το πρόγραμμα.
Ναι. Όχι, αυτό που είπες, μισή ώρα. Μετά μισή ώρα θα συζήτηση. Ναι. Ο Νίκος Σifakis είμαι εγώ. Του κύριο Γιώργου είμαι το Ραμπατζή.
Α, μάλιστα.
Ναι, διδακτορικός του κύριο Γιώργου. Πα.
Και έμαθε κάποια μορφή μηνικήτιδας, ενώ ήταν μικρός. Και με τα πόδια.
Να τους βάλεις AirTag. Πόσες ώρες έχουν βάλει την εβδομάδα σου? Πόσα μαθήματα, δεν σου έχουν τόσο ακόμη.
Μαθήματα.
Μόνο.
Σχέδιο επιλογής επιδοτήσεων. Είναι πόσους φοιτητές όμως θα είσαι?
Την προηγούμενη, πόσους?
Πόσους 60.
Όχι το καθένα.
Το καθένα.
Α,
Το
ναι.
καθένα. Στα δύο υποχρεωτικά.
Ναι, εννοείται.
Μιλάμε
Με το συντεκνό μου.
το μέχρι χτες. Να, χτες μου
Κάτσε στο.
γύρω το το τελικό φίλτρο και αρχίζει να βγάλαμε
Δεν τέτοιο, ρε.
και εκεί πάνω που την έκανα τη δικιά μου, δεν το μαλάκα πώς έκατσε και είπα. Γιατί έλεγα και εγώ ένα σωρό πράγματα. Δηλαδή δεν ξέρω τι πρέπει να τα γράψω.
Γιατί εμένα δεν μου πάνε να τα γράψω εγώ. Αυτοί δεν τα γράφουν αυτοί.
Τυχερός είσαι. Με λέει στην αρχή, ξέρω μου τι είσαι εσύ, θα το γράφεις όλο. Ήταν παραγωγής. Γιατί είχαμε 40 λύσεις, οπότε...
Ναι, αλλά εμείς ήμασταν 2 ώρες, η Μάρια.
Και τότε δεν είχα.
Yeah.
Ο άλλος ήταν από την Αγγλία, ήρθε να μας πει την ιστορία της ζωής του, ότι κάνει μαθήματα στην Κίνα, ότι κάνει μαθήματα στην Αγγλία και ότι εν τέλει η γυναίκα του είναι στο Ιταλικό. Και αγοράζει πίσω. Θέλω μια θέση.
Είδα φως και μπήκα.
Είχα κάνει κάτι στηριακά από το
Ναι.
Ότι όλα αυτά πρέπει να γραφτούν με ένα ωραίο τρόπο.
Μα αυτό είναι τώρα το πρόβλημα και σε εμάς. Επειδή έγινε χαμός με την άλλη, γιατί πήγε κατεύθυνση επόμενη, το οποίο με έκραζε. Και πρέπει να το μαζέψουν και να το μαγειρεύσουν, γιατί αλλιώς. Το θέμα είναι ρεσιμάρια. Τα υπομνήματα αυτά είναι δημόσια, δεν είναι?
Γι' αυτό σου λέω elegant words.
Εγώ πάντως αυτό μπορώ να κάνω τέτοιο. Να τις κάνω μήνυση για σκοσφατική διαφήμιση. Ωραία.
Αν σου πει μαλακία σκοπατική διαφήμιση, εγώ στο πρόσωπο σου άνετα. Εντάξει. Βασικά αυτή τα τρεις.
Ναι. Εγώ απλά μια μήνυση θα κάνω. Κοίτα, το θέμα είναι ότι αυτή η κακομοίρα είναι δημόσιος υπάλληλος, είναι στο Δήμο Χερσονήσου σου. Δεν ξέρω. Και δεν ξέρω και πόσο χαζομάρες είπες, γιατί σου λέω με πήρε ο πρόεδρος. Όχι, δεν ήξερα τι τέτοιο, τι υπόθηκε.
Δημοσίευσες με λίγο και αυτή τα φάγαμε ξέρω εγώ αρχείο.
Εντάξει.
Όχι να ούτε το Υπουργείο, κανείς δεν πρόβλημα.
Όχι, τα έχω ελέγξει εγώ τα νομικά το κομμάτι και εντάξει. Τα έχει ένα κοντοχωριανό μου.
Ναι.
Το ξέρω.
Ναι.
Πολύ καλό το παιδί. Ναι. Παλιά. Από το 12. Ήμουν στο Μπέρ, άμα διδακτορικό μετά στο Μπέρ, και μετά πήγα στο Ραμπατζή πάνω. Ναι. Δεν το ξέρω έτσι είστε καταγωγή από τους Καλάνι. Δεν το ξέρω.
Με Φωριανοί είμαστε.
Το Σταύρα. Όλοι τσάινα. Το pointer δεν με πολύ νοιάζει. Εντάξει, αυτό είναι καλό. Όχι. Αυτό θα το παίξω. Αυτό μου αρέσει το μπρος πίσω. Α, εγώ νόμιζα να δείχνω. Δεν θέλω εγώ να δείχνω. Να μου τσεκάρεις ότι δουλεύετε μου.
Α, περίμενε.
Δεν το κάνω. Σίγουρα.
Ναι, θα το τσεκάρουμε. Θα μιλάς. Θα μιλήσεις. Μίλα.
1, 2, 1.
Okay, let's finalize. Konstantinos, don't it? Let's finalize the today workshop with the, let's say, last but not least talk from the good friend and the TUC researcher, dear Nikos Sifakis. A guy, let's say, with great experience and I would say in digital passports, in decision support systems, in terms of industry right now. So, and today I see that we are going to see a new term there, which is also very, let's say, valuable if you like, and makes a lot of sense. And this is nothing other than digital shadows. So I will not say more. I will just leave the floor to Nick to talk about digital shadows, energy systems, and CVC.
So, thank you, Maria. Good afternoon, everyone. Thank you all for bringing us together. We are very glad to be here. I'm here to represent our team, the Indigo Research Group. So, actually, what we are going to face today is to answer the question, what real decision a real health element forecast should change. So, the central claim here is that digitalization creates value only when it helps someone take an authorized decision. Actually, we have the data cleaning, the modeling, the forecasting, which are essential, of course. But, they remain support work if something is not changed, if they don't help to feed an action. So, today, we will talk about moving from a decision problem to digital shadows, to energy system evidence, and then to circular value chains, and finally, to a practical synthesis of all of these. So, the common thread here is observation, inference, decision, and at last, accountability. So, today, obviously, you have heard about data cleaning, data preparation, forecasting, and all of these mathematical tools and models to help with the rare earth elements behavior. But my talk today is about the next question. Who acts on the forecast? Within what mandate and with what evidence after this? So let's say that we will need for this talk to reframe critical raw material exposure as a decision problem. It's not only a data problem. Actually, better information may help us, but only if the actors in the chain, the ones who make the decisions, are coordinated through this data and act towards it. So, the Critical Raw Materials Act gives Europe some, let's say, important targets for the extraction, processing, recycling, and supplier dependence. But those targets do not automatically tell a specific company what to do. They tell what to achieve. So how to do it and how to make decisions is something that they need to rely on their data and get some insights from this data. Otherwise, they are just numbers. So here we have exactly the gap decision-oriented digitalization, the gap that decision-oriented digitalization must fill. So, as I said, in the rare earth element chain, the main pressure points are the separation, the alloy production, and, let's say, the magnet making, for example. The uncomfortable pattern is that the most critical stages are the least visible to public data. What we mean here, what I mean is that actually those who take decisions do not have actual access to data. They are the ones with the least sensor data available. So this is something that we will discuss a bit later. So here, as you already know, the value chain of CRMs has a lot of factors. There is no single controller that can optimize everything. So a forecast sent to someone without the authority to act is not decision support. It's just an insight. It's just an opinion. So we need to provide useful information to those who act, to those who make decisions. The mismatch is simple. As I said before, the actors with the best sensors have narrow authorities, and the ones with wider influence often see information about the chain on a poor basis. They have limited access to data and to insights. So this is something that we need to resolve. We need to resolve the visibility that actors actually have on the whole value chain. So, in order to make a decision, we need to have some parameters. It's not a single objective problem. It's a multi-objective problem. As you know, the decision quality that we may propose does not depend only on forecast accuracy, on how good the forecast models we will create are. It also depends on the speed, on the latency, actually, on the authority and the available actions. It's really, really important to provide an action space to the decision makers, to the ones who make the decisions. If we force them to have only one option, then this is not the case. We are not optimal. We are not, how to say it, we are forcing things. So, the most failed digitalization projects fail in familiar ways. What I mean, we have some dashboards that do not force action, do not provide insights. They are just some graphs, some numbers, and that's all. But that's not here the case. We have models that are kept into our computers. They are not deployed. We have some correct outputs that have no owners, actually. We have some outputs from our models, but we do not share them with the ones that are actually interested and are the ones that make the decisions. And lastly, and most importantly, we have some claims at all that cannot be justified. So these are all that need to be synthesized. They may look technical, but they are really decision layer failures. Now, we have 3 research questions, and the rest of the talk is organized around these. The first one is, what kind of digital representation is enough? How the decision layer should be designed, and how value should be measured. The real object of interest is not the platform, actually. It's the decision. So, let's move to the digital shadow concept. Let's define digital shadows carefully. We need to be very specific on this. A digital model is just a virtual representation of a system. The digital shadow is refreshed real-time from the system, while the digital twin is a bidirectional system that can get information from the actual system, but can change some parameters to this system, actually through some actuators, let's say. So, let's move to what the digital shadow actually contains. As I said, the digital model is offline. A digital shadow follows the physical system one way, while the digital twin also acts back on the physical system. That distinction matters because, you know, advising a person and moving an actuator are completely different cases. It's different to have a digital twin that actually makes and applies the decision, actually acts, the digital twin acts, but digital shadow informs and let the decision maker decide what to do with some insights, with some propositions, and some suggestions that are really justified. So, someone would say shadows, digital shadows, are not that important as digital twins. This is not true. Digital shadows have a very specific role, while digital twins have a different role that serves different needs. So, basically, as far as I'm concerned, at many cases, and from my experience, I can say that a digital shadow rather than a digital twin is often the right engineering choice, because in systems that are really dependent on safety, liability, and organizational boundaries, a digital shadow is more useful than a digital twin, because the ones that decide get justified insights rather than a system that decide for themselves. Especially for safety issues, this is really, really important. The real weakness actually is not the open loop that these systems create. It's a shadow that ends in a screen instead of a decision. What I mean here? Mainly, during the past years, and a lot of people, me included, were creating digital shadows and provided their results and their outputs into just dashboards, some graphs, some numbers, and that's all. But that's not the case. Actually, what we need to do is to inform the decision makers through this digital shadow or dashboard or whatever. What decisions can you make through this data? Which are your options? Which are our suggestions and why? And let them choose. So a working digital shadow has 5 operating layers. The first one is the sensing layer. The second one is the quality control. The third one is the state estimation. Then we have the inference. And lastly, we have the decision and accountability. The first 4 layers are usually well understood and are the ones that are really often handled through past projects, bibliography, etc. But the 5th one is where most systems become vague. This is what is missing. So here we want to introduce the term of soft sensors. Soft sensors actually are sensors that are not real. They are just mathematical models that represent a system, represent the operation of a sensor with great accuracy, with great performance, and can actually be there to give us some insights on something that we previously didn't know. We make some forecast, we make some predictions in order to get to know better our systems, our processes at all. So this is really important because most important critical raw material variables are not often directly measurable, as you probably know. We need to infer them from some, let's say, proxy signals, and we must carry the uncertainty forward. We have an uncertainty from the proxy signals. So we must carry this forward instead of pretending that this estimate that we have is an actual measurement. Here I need to, I thought that it could be very good for you to showcase everything on my actual expertise, which is the digital shadow of Impress, a port-related energy digital shadow actually. And here we don't want to say that energy is, the energy sector is the same as the critical raw materials one, but they share some common challenges and processes. I will explain. So here I want to show that the full chain starts from sensing and data to inference and then to scheduling some decisions. The key lesson here is the sequencing. We have something that moves step by step. We define the decision owner first, then we'll build the model, and then we get the decision. So here are some different model families that are used in our, let's say, case. We have tested all of them, and we can see that other methods have some strengths on very specific things, some others fail, but the model choice actually start from the failure we cannot tolerate on our cases. What I mean is that for rare earth element chains, Then dangerous failure is the silent confidence during, let's say, a regime shift, such as an export restriction or a plant outage. So here we need to create some models that are interpretable. This is not something that is only about making users feel comfortable. No, it's about making a model output contestable. Actually, if an output cannot be challenged, then it will not be trusted. And if it's not trusted, it will not make a change to a decision. It will change nothing. So, as I said before, we don't need digital twins to do the job for us. A loop doesn't have to close through some automatic control. It can close through a human decision if the outcome is measured. We need to be able to measure the outcomes. Without comparison against a counterfactual, we cannot prove that our digital shadow created some value. So let's use the energy systems as an evidence for this. This is because their physics are unforgiving, actually, and their decisions are measurable. This is why we use this case for the, let's say, the evidence base for today's talk. If this decision-oriented logic works here, it can be a credible candidate for material value chains as well as the ones that we are interested in. Energy systems, as you may already know, force discipline through some balance constraints. As you know, energy balance holds every second, or the system fails, or we have a problem. Then we have some competing objectives and some observative counterfactuals. And the most important thing is that we have very specific constraints. We must respect them and we must build upon them. On our case, with critical raw material chains, we differ technically, but they share actually the same decision structure. Another tool that we may use for our cases is the operational research. Actually, what operational research does is that makes vague choices explicit by defining what we control, what we optimize, and which limits or constraints we must respect. We must respect. We cannot defy them. So, this does not remove judgment, of course, but it makes it visible, measurable, and easier to discuss. As you can understand, uncertainty is the most important problem that we tend to face, we tend to model, and we need to include in our cases. We cannot defy uncertainty. We cannot work without uncertainty. What we can do is to model it efficiently, effectively, and include it into our models. I usually like to say that a good model is the one that can, through its errors, handle uncertainty. So, as you can understand, this is a part of the decision problem. Rare earth element shocks are often political or administrative. You know this better than me. So the system must remain useful when the future is not drawn from the past. Actually, this means that the best solution is rarely the one that performs optimally on average. It's the one that remains operable when the environment changes, when we have increased uncertainty, when we cannot predict what will happen. So, when objectives now conflict, we have some multi-criteria methods that make the value judgment visible instead of hiding it inside the default weight. The important question is not which formula or method or model is the best. Nope. We don't care about which is the most clever option and solution. It's what gets to set our preferences. Here we have an evidence through cooperative energy that we can see that organizational design can leave a measurable energy footprint. This means that we have something that can be measured and can help decision making. This can actually help us decide and suggest some, let's say, optimal options that we may have. Here, the exact causal claim is somehow cautious, but the standard is important. If an intervention that we are planning to do matters, then we should be able to measure its effect. If we are interested in something, then we need to be able to measure it. We need to provide numbers. We need to have justification. Why we do this? Why we want to do this? Why is this important to us? So, returning to the port case, we have the evidence that follows the same pattern. We have the field data, then we have some quantitative analysis, we have the models, we have a documented performance, and then we conclude to decision support. If we have no decision support, then we have nothing. We have some numbers that are good for us, for researchers. The decision makers have no use on this. They are not interested in this. They don't care to tell them that you are spending this, you are doing this, you are doing this. They are caring how to reduce the cost, how to reduce the energy demand, how to make the system more reliable, more, more stable. So we need to provide answers. We need to actually inform the decision making through this. And here are the standards that come into play. The standards enable the accountability, which means that they matter because they turn a performance claim into something comparable and auditable. Okay, we have some numbers, we are measuring everything. Without standards, we don't know what we measure actually. We don't have something to compare with. Okay, we may have a baseline, we may have, let's say, we have an intervention, but what's the standard? What's the baseline of other cases? So, let's say we have a shadow that produces numbers without some stable indicator definitions. This means that we have a shadow that produces evidence that no one can reliably use. We need the standard for it. Now, we need to move to circular value chains. The key idea is that circularity fails not only when a material is lost, but also when information about that material disappears. So, recovery actually needs 4 information functions. The first one is to locate the stock. Then we need to characterize it and know what it is included of. Then to price it, to see if it is worth it. And lastly, to certify our claim. Actually, this means that can we prove what we say? An example is that better chemistry alone does not tell us, let's say, where magnets are, but it tells us what they contain, what they are worth, or how to prove it. The material loop may continue, but the information loop may break at the handovers. So this is the most important aspect. We lose information through all this process. And as we lose information, we lose more and more and more information. And at the end, the decision maker receives scarce information on what to do, on how systems now operate. So what we need to do is to preserve this information, turn it into accountable insights, and help decision makers make their job and their life easier. So, a useful digital shadow must preserve or reconstruct the identity, the composition, the provenance, and the condition across all those breaks that we have on our information. And now, the most important, I think, for you aspect of today's talk is traceability. This is what a digital product passport actually does. This is a new initiative from the European Commission. It's a new legislation that I think this will be obligatory in the near future, and digital product passports will help us and make us observe and have a look at every part product here, from being a raw material to synthesizing it to something else, to the consumer, and then to its end of life. So, through traceability, we can reconstruct how a claim was produced. If we know what happened, we can strongly justify our claims. On the other hand, we have verifiability, which means that the claim meets the physical reality. And this is what a digital product passport thrives to achieve. So, a shadow here, a digital shadow, can help the whole process, as it can support traceability, but the verification still needs independent evidence, such as, let's say, sampling, inspection, or mass balance checks, and other things regarding all the process. So, as of now, we know about the static footprint, which tells us an average historical number. But a shadow-fed footprint can describe this batch, this route, or this production window, and creates a dynamic footprint. Once the number changes with operations, it can become a scheduling decision. We have, let's say, we have a schedule set, and something doesn't go as planned. Then we need to reschedule the whole operation. We don't continue keeping this, let's say, problem with us. We try to resolve things. So then we move to dynamic secondary supply. It's not something simply viable or unviable. It becomes viable in windows that open and close. A good shadow should help identify those windows before an investment or an operating decision is made. And then we have different forecasts that serve different decisions, so we need different horizons and different error tolerances. Not all models are capable of solving all the problems. Different models, different problems, different models, different tolerances. So here we have the synthesis of all these, which is the final section, and asks what must be added to turn a shadow into a decision-oriented digitalization. And the answer is a clear decision layer. We need a decision layer integrated into our systems, into the very end of our systems. But this is not, let's say, the last thing to do, something to do because we must do it. No, it's last but not least. It's something extremely important to us. It's a way to measure value and a realistic view of where the approach, our approach, can fail. So, a decision layer specifies the object of the decision, the owner, the objective, the constraints, the action space, the latency of the decision, which means actually the speed of taking a decision, how fast are we on making the decision, and the audit trail. If any of these pieces is missing, then the model may be impressive, but it's not working. It's operationally weak. We need all these pieces to make a model useful. So we have a cycle here. the complete cycle starts from observing, then we go to inferring, then we are deciding, and at last, we account for the result. Accountability is not paperwork. Actually, it's how the system learns whether the decision was worth taking. Okay, we did everything. Was it worth taking? Was it worthy? Here, we use the model metrics, which tell us whether the estimator, our model, performed well on data. But this is on data. The ground truth versus real conditions differ a lot. So the decision, we need to use some decision metrics on this. And these are that tell us if the project was worth building, if what we decided was actually good, was actually the best option, because they measure regret, latency, adoption, and actually the realized value. So what we decided was worthy. So something that is really important is that forecast values are often saturated. What I mean, the forecast value often saturates once the decision threshold is clear enough. After that point, as you can see in the graph, more accuracy may be technically satisfying, but economically unnecessary. We thrive to better and better and better and enhance our models, but actually they give us nothing on the actual decision at the end. So we don't need, as I said before, the best model. We don't need the best numbers. We don't need to have, let's say, the most well-performing model. No. We mean and we want to have the model that does the work efficiently and effectively. So here you can see that we have a maturity scale that helps us separate simple digital records to dashboards, to digital shadows, to decision systems, and true closed-loop twins. The step from a dashboard to a decision system is usually organizational, not technological. The technological, how to say it? What we need to do into technological terms is not that important as the things we need to do on organizational terms. We need to reorganize everything to be on this part. So some of you may have some, let's say, legitimate objections to my argument, especially for the exploratory science, market intelligence, and cases where, let's say, information has an option value. But my claim is therefore not universal. It's a strong default for industrial digitalization. This is what we research. This is what we have tested on. I cannot claim this is universal, but I can claim this is something that works well and is the case for industrial digitalization. So a research agenda can include and produce things that can be tested and can fail. That means we need to have decision layer specifications, value metrics, validation protocols, governance rules, and also transfer tests across many, many domains. Back to my experience across cooperatives, ports, and critical raw material chains, the technology changes, but the decision calculus repeats. This remains the same. So this is why this is a research pathway. This is why we suggest it. We suggest a research pathway and not just a collection of separate projects, methods, models, and let's say operational research things. For our rare earth element forecasting, The practical implication is to start every pipeline by naming the decision it serves. Then we define the actor, the horizon, the action space, and the evidence needed to defend our result, to defend our choice. And the core conclusions is that digital representations matter only when they end into a decision. Shadows are often enough, but they must connect inference to authority, action, and accountability. Thank you very much.
I think we have some time for questions. Thank you very much, Nikos.
Thank you.
Are there any questions? Do you have? Okay.
First of all, thank you very much. Really nice presentation.
Thank
you. For our project, the MaaSiveTwin, I'm part of the sustainability part, creating a model to fit also the big model. And I'm also using AHP, Topsys, and Prometheus 2.5. And I have a question, because you also use those models. The expert or the questionnaire that you did in HAP or for a Prometheus for weighting and this, did you do just one questionnaire and use for both cases, or did you split it, or was sorry for
No, it's it's a really good, interesting, and straight to the point question, because this was the problem when we started using these methods, because we needed to use the questionnaires to calculate the weights for our methods. Am I right? So good. So far, so good. We used one questionnaire. We had some, let's say, respondents, 100, 200 respondents. We were above 60, so we were statistically okay. And then we have the problem that we have some additional tests on our questionnaires that actually provided some bias. Because, you know, if I share the questionnaires on people around the Technical University of Crete, there is some, let's say, bias on this. There is some small bias on this. What we did, it's not changing or creating more and more questionnaires. Nope. We shared the same questionnaire to different places, to different people, so we eliminated this, if I understood well, this bias problem. So then, after sharing the same questionnaire, the same tool to different people, to different areas with different biases, then we combined, we fused all this to calculate some unbiased weights for our models.
Perfect. Thank you very much.
Thank you.
Thanks for the great overview. I did not understand one part of your talk regarding the, like when you talked about these savings there in energy, this is one example. So I did not quite get what was the role there of this digital shadow and who was making what decisions and how did the tool help in that example? I did not quite understand that. Could you maybe elaborate a bit more on this?
Of course. Thanks for this question, because this is the field of my expertise, actually, the actual expertise. So the digital shadow is actually a virtual representation of the port energy system that shows us how the port behaves across, on hourly basis, across the day. So giving us a picture of the port's, let's say, behavior on the aspect of energy demand, then we can make decisions on this. What we did on our digital shadow, we set some thresholds, we fed it to an AI, to an LLM, to a large language model, and then we had this LLM to decide some things. Let's say, for example, we had the problem that some people into this port turned on the air condition on midday full. I mean, they turned it on 20 degrees Celsius. So the energy demand skyrocketed. What we did is to provide some insights to the port personnel to stop doing this. This is not working efficiently on this. You can increase, let's say, the temperature to 24, you will get the exact same output. Maybe you will get better indoor, let's say, comfort, and you will spend less energy. But without having the digital shadow observing these peaks on the energy demand, then we wouldn't be able to identify this, to know what's going on. This is how we used the digital shadow, and this is a simple case.
And could you validate these savings in the actual case, so in the real world, or could you only calculate them in the digital, based on the digital shadow? So how much of these calculated savings did actually materialize, and after some time then?
Okay, this is the tricky part here. Now we have advised them to do so. We don't know what will happen in the future, but we have advised this. I can tell you that through some simulations that we did and some virtual representations of the system that and some scenarios, what if scenarios we ran and got the results, the savings were more than 30%. 30% is a lot regarding energy. It's a really good measure, but who will persuade them to follow our suggestions? This is what we need to measure now. Are they doing what we are asking for? We cannot force them. So we help the decision making, but we cannot force it.
Other short questions or large questions from the last survivals? Nope. So Ken, Nick, thanks again once more.
Thank you very much. Thank you.
And just the last few words, let's say. Thank you very much being here from morning on. Sorry it was like quite long. I hope that you learned something, at least from the very basic of a time series analysis, a satellite image analysis about mining monitoring, then some provocatorical thoughts and actual pessimistic what happened in Europe, which is actually the truth, and ending with something that we see the tomorrow, let's say, of what we expect from these systems. Thank you all very, very much. And of course, the online people, slides will be available. Also the live coding we did in the morning. Thank you very much. Have a great day and take care with this warm, very warm weather. Yes, please.
May I just add a few words? On behalf of the participants, I just want to thank you, Marius, for organizing this great consortium meeting and for organizing these this workshop, the inspiring talks. Thank you very much to all the speakers. So I think it was really very insightful, and let's give an applause for the great organization. We really enjoyed it here.
And we close here. Thank you.